Do you think he knows that it's not recording?
Hey Matthews, we're looking at Quartiles, Interquartile Range, and Box and Whisker plot. It's out of 6 F and G, and it starts with the measure of dispersion or the measure of spread, how spread out the data is, and a simple way to do that is with the range. And the range is just the distance between the top and the bottom, the max, the min values. So in this case, the range is 2. All right. If you, maybe we looked at different data like this, right? The range would be between 1 and 9, the range is at 8, right? So there's an 8 jumps between my lowest score and my highest score on our quiz. Another way you can, and so that's fine, but sometimes that doesn't really show you how spread out the data might be. And so there are other measures to show how spread out the data might be, and quartiles and interquartile range are the next step. A quartile is, as it sounds like, breaks the data into 4 chunks, even chunks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I think this is going to be the middle. This is going to be my bottom set of data, and that's going to be the upper set. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Great. So we've broken the data into the top half and the bottom half, and then the quartiles are within that, breaking the data up into the bottom 4, or the bottom quarter, middle quarter, upper middle quarter, and then the top. We call this quartile 1, quartile 2, Q2, Q3, and Q4. And this gap between the Q1 and Q2 and this gap between Q3 and Q4, that's what we call the upper quartile like cutoff and the lower quartile cutoff. And so these are the quartile range for this data set. The median is always right between the upper half and the lower half of the data set, so right there is the middle. And the interquartile range is the distance between here and here. So our lower quartile cutoff is this 3, and the upper quartile cutoff is this 8. So the interquartile range is another way to show the spread is the 8 minus 3 is like 5 units between here. Now we use that to sort of compare this data to other data sets. It's not that interesting with this by itself, but if you had another class's quiz scores, you could compare how spread out they were. You can also see this, a large IQR or interquartile range. Like notice that these have the same highest and lowest values. If these are all our quiz scores, this curve has most of the data concentrated in the middle, and so this is going to have a low IQR, the black line, because most of the data is centered right in here in the middle quarter. The green has a large IQR and data is more spread out, so the quarter of the data is here rather than here, and it just means that there's more spread in that data. Maybe we're more skeptical about the predictions of our statistics. All right, so let's have you try that. Find me the mean, median, and mode for this. Also Q1, where the middle breakup is, the Q3, and the interquartile range. I would like you to try this by hand so you appreciate what is coming next. Try that out. And one of the things that kind of requires is ordering it. So write it down, order it, and pause me after you find those pieces. All right, so there's the ordered set. If you laid it out, there should be 20 terms. And if you're finding the mean, well, the median's easy. It's between 6 and 6, so it's 6. The mode, it looks like maybe 4. I think 4 is the mode. And the mean is add them all up and divide by the number of numbers. So you'd add 1 plus 2 plus 1 plus 1 plus 2 plus 2 plus 4, blah, 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 add them all up and divide by the number of numbers. So I put in mean, median, mode, but you should be able to find the mean there. Q1, so this is the median. So this is the bottom half of the data. If there are 20 pieces of of data. This is 10 units, and so there should be, in the bottom half, there should be 5 and 5, right? This should be 5 sets, 5 entries and 5 entries. And so I think that this is going to be, 4 is going to be Q1. Similarly, there's 5 data points there. Oh, missed. There's 5 data points there. There's 5 data points there. Q3 is going to be right between them, so 9.5. Cool. So the interquartile range is the distance from there to there, so 5.5. Shows us how spread out the data is. Now, we don't want to do that by hand all the time, so we want to be able to take this same data set and put it into your calculator and have your calculator do some of the work with it. I took the liberty of punching those values in already. You go to Stat, you go to Edit. Here's 6 and 4 and 9 and 15 and 5, just like this is the same as the last problem, right? One neat trick is that if you want to have this sort for you, you can go back into Stats and go into Calc. Oop, sorry, just in Edit, and go to Sort A. And then this means please sort from A to Z or Z. I want to tell it which list, L1. All my data is in list 1, right? All my data is right in here in list 1. So please sort list 1, close the parentheses. It says done. When we go back into Stats and say Edit, it's all listed out just like we saw before. 1, 1, 1, 4, 4. Maybe I put in. May have put in too many ones. Yeah. Either way, I think there's only supposed to be 2 ones. I plugged something in wrong, so my graph's going to be a little bit off. Okay, so from there, that's nice. That's helpful. From there, we want to find mean, median, and mode, and all of that stuff from the calculator, not have to do it by hand. So take your data set, right, go back to Stats, and have it calculate. So Stat, Calc. And then we want one variable statistics because we just have one thing going on. We have your score, right? So you say one variable statistics, list 1, freq list, don't put anything in there, hit calculate. Mine's going to be different because I obviously put something wrong in, but this is the values you should get, right? This means the mean 6.75. This one is mean. These are standard deviations. We'll get there soon enough. This is the number of terms if you didn't want to count them. And then here's your this is called the 5-number summary. Your minimum value, your cutoff between your Q1 and your Q3, the median cutoff between Q3 and Q4, and the top value. Cool? Bing. So from that, then we can make box plots from this 5-number summary just to visualize what's happening. Instead of writing out those boxes with the data points like this, we're just kind of making this box and whisker plot where this is the middle and this represents a quarter of the data, a quarter of the data, this is a quarter of the data, and this is a quarter of the data. We show it as a box because most of the data is right in here, half of it's right in there, and you kind of it breaks it up a little bit so you can see it and compare box plots a little easier. Same data set. Here's our median. This is from our calculator. Right, here's the breakup between Q1 and Q3. Here's the breakup at 9.5 between Q3 and Q4. And so we build a box there, and then this is our minimum, this is our maximum. That in and of itself, aside from having a cute name, isn't that interesting. It's when you compare the two that's interesting. So if you looked at this data, this has kind of a nice curve, and this is symmetrical, right? This is kind of symmetrical, and these are about the same distance out. If you have a negatively skewed data set like that, right? It kind of looks like somebody pulled the tail on this one towards the negative side. You can see that in the box plot because most of the data is crushed in here. That's much of the data. And so this is kind of condensed. It's not very spread out. It's dense right there. And this part is another quarter of the data, and that's really spread out. And you see this as a tail that's being pulled, or a whisker that's being pulled down to one side. Conversely, if you have a spread of data that has most of the bulk as low values and is being skewed to the right, you see that skew as a longer tail and a denser base here, right? Cool, so we can compare the size, the type of skew between those values. All right, so what I'd like you to try is take this data and build a box plot for me with that. Try it by hand once, and I'll show you how to do it with your calculator after that. Order your data, that'll help. Maybe this is like test scores from MYP class. Maybe your MYP goes to 8, right? All right, so first you would want to find the 5-number summary. Maybe you want to do that by hand. Maybe you want to do it with your calculator, but you found the minimum was 2. The maximum was 9. You found a medium, a Q1, Q3, and you built it like that. Right, so your value should be like that. It looks like it's a positive skew, so there's a lot of density down here in the 3s and 4s, and then you have a couple up here. Oh, there's a 9 somehow. The IQR is 3.5 because we're going from here to here, and that's a distance of 3.5. Right? But the range is a full 7 because that's the distance between here and here. Neat. We want to be able to do this with your calculator, and I'll show you that in a second. But also, there we go. So on your calculator, you can do this same thing where you go into, if you want to visualize this, you can go into second stat plot, this stat plot. And right now the statistics are off, but you can turn them on, and you can go down to you have to go over to this box and whisker and turn that on. And then when you have your data, when you graph it, you probably won't see anything, or it'll be crunched in there. So you have to go zoom, standard, stat, because we're using statistics. So the window will zoom in based on what it sees in the list 1. And then you can trace and see these jumps in the medium, the Q3, using your side-to-side cursors. What's nice is you can also do this with multiple data sets and see multiple boxes. Is about outliers, and outliers are data points that we could potentially remove. We can't do it for no reason, but we want to be able to identify them and then maybe see if there's a reason to get rid of them because they might lack statistical significance. It's not just subjective. There's a mathematical idea about when to regard something as an outlier, and that's if something is 1.5 times the interquartile range above Q3 or below Q1. So let me show you that visually. Here's the IQR of this data set. It's from here to here. So here is 1.5 times that, right? Here's 1 times the IQR. That's half of the IQR. So this length is 1.5 times the IQR. If you have any points that are 1.5 times the IQR, I know this is here, but it might be that you have a maximum that's like here, right? That point is beyond this line, and therefore this should be questioned as valid. Same thing with this. If you're 1.5 times beyond the IQR, below Q3, so if you have any data points that show up here, questionable, right? Maybe they're outliers, maybe we want to get rid of them. We can get rid of them if it's like a data collection or entry issue, not just because it shows up, but like maybe maybe my hand jiggled when I was using a ruler or something like that. All right, so let's take a look at that. Here's the data set that you can try, and I'd like you to try to find if there's any outliers in here. It looks pretty bland, right? Here's the Here's the, well, I'll give you the 5-number summary. There it is. It's all laid out for you. Okay. Look for outliers and see what you find. Okay, so I know that the median is here at 8. I know that the Q3 is at 10, that's here, and the Q1 is 6.5. So this is a representation of this. Okay, 1.5 the IQR. The IQR is from 6 to 10, so that's 4. Right, that's 4 units, and 1.5 the IQR is 4.5 of 4, so it's 6 units long. And you can tell that visually this is going from, or I guess that's 7, sorry, from 7 to, yeah, there, okay. So this distance is from here up, that looks like these are okay. And from here down, oh, this might be an issue. So if we test the upper size, the IQR is 3.5. Oh, I guess sorry, Q1 was 6.5. I couldn't see with my old eyes. So this distance between here and here is 3.5, and 1.5 times that is, and then add it to 10, add it to the top to see how far that way, is 15.25. So 15.25 is still here. Oh, look, 16 is beyond that. So my guess is 16 is a contender for being removed as an outlier. Just because it is numerically an outlier doesn't mean that you have to remove it. Test the lower boundary. We do the same thing. We say 1.5 times 3.5. So 1.5 times 3.5. So this is 5.25. So we need anything that's 5.25 away from here. So 1.25 is the boundary. So it looks like that might be an outlier too. You can do this on your calculator. I put in the data into my stats. This is all the data that we were given. And you can show this with a modified box plot. If you go back into stat and you go into here, and instead of this box plot, we use this one. And so I'm going to go down and over. This one you can see the dots. Those are to identify outliers for you. So now we can go back to graph, and there they are. If you can't see it, again, zoom stat. And you might have a messed up graph if you have something in your y equals key, so make sure that's cleared out. And so this, again, you can go say trace, and it'll show you the new minimum should be 3. The outlier should be 1. Median, Q3, new maximum, outlier. Okay? Maybe that's useful, maybe not. We're going to try problems out of 6, F and E. Again, that was out of 6. Sorry about that. Switch up. I like this. Can my boyfriend come along? I'm not your boyfriend. You totally are. You spend twice as much time with me as anyone else. I'm a clear outlier. I'm your statistically significant other. I like that. Do some math and then go spend time with your statistically significant other. Okay, bye.